I'm going to tell you how recursion works, okay? So before I explain what recursion is, I need to explain something else, like how the methods inside, like in the computer, how the methods are working. So this is Java program I have right here. So if I, like, I'm going to make a method, okay? So I'm going to make a method that prints the cube of a number. Okay, so this is the method, the header, and then it's going to, have a number as the parameter, and then it's going to print out, the cube of the number, okay? So I'm going to calculate the cube of the number. So number times number times number is the cube of number, and then I'm going to print it out. So I'm going to say cube of number is cube of number. Now I'm going to call this method with the number 5 in it. Okay, so as you would expect, the output is going to be cube of 5 is 125, because we gave the number 5 over here. Okay, so what happens inside the computer is this method right here, it'll be changed. It'll be removed, and then whatever is the code of this method, okay, will be put instead of here, like inside the computer. This is what the compiler, right? The compiler does. This is the compiler's job. The compiler does, it takes this method right here, and then it removes it, and then puts whatever code is, whatever the code of that method is right there. So if you look at this, the number variable we put as 5. So we have the number here, the number, this number 5 we are using right here, okay? So all of these numbers will be changed to become 5. So if I do that, you see, look at this. So this, the code of the method, see, this is the method right here, yeah? And this thing right here will be put in the place of this inside the computer. So if you look at that, you see all of the numbers here, the number has been changed to 5s. If you look here, 5, 5, 5. Now, then the next step, this is like not an important part, but this becomes 5 times 5 times 5 becomes 125, and this cube of number variables value is 125. So this cube of number also gets changed to 125. So I'm going to start with recursion, like exactly what is recursion, right? So a very simple example of how recursion works in programming is the factorial of a number. So the factorial of a number is a simple example, and I'm going to explain what is a factorial. So a factorial is basically is the product of all the numbers from 1 until that number. So if you have an example, like let's say the factorial of 5 is equal to 5 times 4 times 3 times 2 times 1, which is 120. This is simply what a factorial is. Now I'm going to show you how the code will be, right? So now I'm going to show you like how the factorial method is written, right? So let's define the method. Let's say in factorial, it returns the factorial method. So I'm defining the method, right? So it returns an integer, and will find the factorial of the number n. Okay, so I'll say, okay, if n is equal to 1, then it should return 1. I'll explain what this does later on, how this works, like why is it returning 1 if that does. So else, if it is not 1, then it returns the factorial of the number below it times the number itself. So let's say I have 5 over here. So it will find the factorial of 5 minus 1, which is 4. So it finds the factorial of 4 and multiplies it by 5 itself, and then returns that number. Okay, so I'm going to find factorial of 5. Let's say factorial of 5, and then I say and then I print it out. So as you expect, the output is going to be factorial of 5 is 120. Now I want to show you inside the computer how it works. I want to show it visually. So how it works, like what is this factorial, like why are we getting 120, and how is this method being called inside the method itself, right? The same method, the factorial method, is called inside the factorial method itself. So I'll show you that right now. So I'm going to show you visually how the code works. So as you can see, we have the code, and factor of 5 equals factorial of 5. Okay, now we're trying to find the factorial of 5. Now this code, right, this factorial of 5 right here will be changed. It will be removed in the code inside the computer. This is what happens. It removes this and puts whatever is the code for this method in its place. So what happens? It puts the code for it. So this is the factorial of 5. So we are finding the factorial. This is the code for the factorial method, right? And as you are trying to find the factorial of 5, all the n's here, the n here and the n here, it all gets changed and becomes 5. So this is what happens. So we are going to check if 5 equal 1, and then it will return, or else it will return this part. As you can see, we are returning the factorial of 5 minus 1 times 5. So this factorial of 5 minus 1 becomes factorial of 4, right? So it becomes factorial of 4. And the factorial of 4, this code, right, this factorial of 4 will be changed, right? It will be changed to the code of the factorial method with the value 4 as n. Yeah? So what happens? This is what happens. So factorial of 4 will be changed and put the code of factorial of 4 in there. You see what I'm saying? So it will be if 4 equal 1, and then return 1, else return factorial of 4 minus 1 times 4, right? So this factorial of 4 minus 1 becomes factorial of 3, right? Becomes factorial of 3, and the factorial of 3's code is put there, and keeps going. So you can see factorial of 3 minus 1 becomes factorial of 2, and the factorial of 2's code is here, and then factorial of 2 minus 1 becomes factorial of 1. Factorial of, see, factorial of 2 minus 1 here, it becomes factorial of 1. The factorial of 1 looks like this, right? So all the n's you can see is changed to ones. As you can see, 1 is equal 1 is true, so that means it will return 1. So this code right here is executed, so it doesn't go to the else, so the else is no more valid. Okay, now this is the reason why we put this condition. So we want a recursion function always has this like the ending condition, like the condition that stops the recursion, right? There will be an end condition, so you'll keep going until you reach a point where, okay, it's no more, it no more keeps doing the recursion, right? No more calls the same function itself. So that's what this if 1 equal 1, I mean if n equal 1 does. So it reaches point where n equals 1. That point we want to stop the recursion, we will just return the number itself, we will return 1. So what happens, this return value will be put here instead of factorial of 1. So this factorial of 1, this part right here will be changed, and the value 1, whatever the function returns, will be put there. So what happens, we can see it becomes return 1 times 2. Okay, it becomes return 1 times 2. So the factorial of 1, this thing right here, will be changed, and it will be as 1, and it will return 1 times 2. And this whole method from the memory, it will be removed, the memory stack. So from the memory stack, this whole method here for factorial of 1 will be removed. So it gets removed. And then now we'll calculate this. Return 1 times 2. So 1 times 2 is 2. So it will return 2, and the same thing happens. So factorial of 2 will return 2. So this factorial of 2 will be removed, and 2 will be put there. So it becomes return 2 times 3, and the whole method will be removed. And it keeps going. Okay, so return 2 times 3 will become return 6. So it becomes return 6. So factorial of 3 will be removed, and 6 will be put into place. So look at return 6 times 4, and then this whole method will be removed. So it becomes return 6 times 4. So return 6 times 4 will become return 24. Okay, so return 24 will be returned, and it will be replaced in the place of factorial of 4. So the factorial of 4 will be replaced with 24, as you can see, return 24 times 5. Now this whole method will be removed from the memory stack. And the last step, so return 24 times 5 will be return 120. And as you know, this whole code was factorial of 5. You're trying to find factorial of 5, right? So the whole code was return factorial of 5. So this whole code, okay, will return 120, and this factorial of 5 will be replaced with the value of 120. So it puts 120 over here, and the whole method here will be removed from the memory stack, and we get this.